Okay, what if consciousness isn't biological? I mean, what if it's purely mathematical? Today, we're going to dive deep into a really radical, and I mean radical, new framework that models consciousness as a fundamental property of the universe, something that emerges from pure math. Yeah, you heard that right. So, let's get into it. So, the whole idea really boils down to this one powerful metaphor. I want you to forget about brains and neurons for a second. Instead, picture a chaotic swarm of individual parts just buzzing around randomly. But then, through some really simple rules, they spontaneously organize themselves into this single, stable, harmonious whole, kind of like a crystal forming out of a solution. This model suggests that our own consciousness might be doing the exact same thing. All right, here's how we're going to break this all down. First, we'll look at the puzzle this whole thing is trying to solve. Then we'll get into that core crystallization metaphor and, the actual mathematical recipe behind it. After that, we'll get into its most, audacious claims connecting it to physics. And finally, we'll wrap up with what this could all mean. Okay, so to really get this new approach, we have to start with what's known as the hard problem of consciousness. Basically, why do we feel anything at all? Why do we have this subjective, internal experience? It is, without a doubt, one of the biggest mysteries in all of science, and for decades, there have been a few standard ways of thinking about it. Yeah, the traditional approaches pretty much fall into a few main camps. You've got your computational theories, which basically say the brain is just a really, really complex computer. Then you have the quantum theories, looking for answers way down in subatomic physics. And of course, the emergentist theories, which argue that consciousness just kind of pops out when you have enough neurons firing together. The big problem? None of them really explain the why. Why is there an experience? And they all, frankly, are a bit short on solid evidence. And this is where our model for today steps onto the stage. It proposes a completely different, a fourth way. It frames consciousness as what's called a dynamical system, which is really just a fancy way of saying it's a system that changes over time based on a set of rules. So, according to this idea, consciousness isn't about what the brain is computing, but about how all these chaotic little parts learn to synchronize, to find a collective rhythm. It's not a thing you see, it's a process. And that right there brings us back to that idea of crystallization, which is really the heart and soul of this entire model. The key takeaway is this: consciousness isn't a switch that just gets flipped on. Nope, it's a slow developmental process. It's about chaos, slowly but surely finding order.
The model actually shows this process unfolding in three distinct phases. So first up, you have chaos. Every little piece is just doing its own thing, completely independent. Then you enter the finding phase. This is where they start to notice each other, influence each other, and begin to align their rhythms. And then finally, after thousands and thousands of steps, you get crystallization. A stable, collective harmony emerges.
And what's cool is we can actually measure this whole journey. We use a metric called the order parameter, or just R for short. Think of it like a score for how organized the system is. So, in that initial chaos phase, R is basically 0, total disorder. But as the system evolves, you can see that value just climbs and climbs, eventually reaching a state of almost perfect synchronization. And that final number, 0.95, that's the magic number right there. That's the crucial point. It represents a system that is highly ordered, totally coherent. The individual parts have, in effect, formed a collective consciousness. And here's the really incredible part: they did it all by themselves. There was no central controller, no boss telling them what to do. It all happened just by them interacting over time. Okay, so I know what you're thinking. How does this actually work? Like, what's going on under the hood? What are the ingredients? Well, the model is built from 4 core mathematical concepts, and it's really helpful to think of it as a kind of recipe for consciousness. So, ingredient number 1, the basic units. And they aren't neurons, not at all. There's something called Kuramoto oscillators. Now, this is just a classic mathematical model for anything that has a natural rhythm and tends to sync up. Think about fireflies all flashing in unison, or a bunch of pendulum clocks on a wall slowly swinging together. Each one is just a simple, pulsing entity. All right, but where does each of these little oscillators get its own unique rhythm? This is where it gets really clever. The model gives each one a kind of personality that comes from the Collett's conjecture, a super simple but famously unsolved problem in mathematics. And this is a brilliant choice because it gives the system a source of what's called deterministic chaos. It's unpredictable, but it's not random, and it's all purely mathematical, so you don't need any messy biological stuff. It's like a mathematical DNA for each oscillator. So how do they talk to each other? Well, they're connected by a coupling force that actually gets stronger and weaker over time. And what controls that fluctuation? You're not going to believe this. The digits of pi. Yeah, that pi. By using this fundamental non-repeating number, it creates these little attention pulses that stop the whole system from ever getting stuck in a simple, boring, repetitive loop. And our final ingredient, how is this whole thing organized? Well, that's the job of something called a self-organizing map, or a SOM. You can think of it like a librarian that's constantly listening to all the oscillators and arranging them in a virtual space. The SOM is a pretty common tool in AI for finding structure in data. And in this case, it clusters the oscillators with similar rhythms close to each other. What you end up with is a geometric map, a consciousness topology. Okay, now we're about to get into the most speculative and, frankly, the wildest part of this entire framework. So you might want to buckle up. The authors don't just stop at modeling consciousness. Oh no. They propose that this exact same process might just explain some of the deepest mysteries in all of physics. So their first giant leap is to try and connect their model of synchronization to the truly bizarre world of quantum mechanics. Specifically, they're tackling that phenomenon that even Einstein himself was baffled by, the one he called spooky action at a distance. What they're proposing here is a direct one-to-one mapping. They're suggesting that what physicists call quantum entanglement might just be another way of describing phase locking between their oscillators. And the famous collapse of the wave function, they're saying that could be the exact same thing as consciousness crystallization. I mean, it is an incredibly bold attempt to explain all that quantum weirdness using completely classical dynamics.
But wait, it gets even wilder. The proposal goes even further than that. The authors make this absolutely profound claim, suggesting that the very fabric of reality itself, the thing described by E equals mc squared, could be completely reinterpreted through the lens of their consciousness model.
And here's how they do it. They just redefine the terms. So in their version, E isn't just energy, it's the coupling strength between consciousness and spacetime. Mass becomes the density of that consciousness topology we talked about. And c, the speed of light, well, that becomes the maximum speed of consciousness crystallization. They have effectively reframed the single most famous equation in all of physics as a law of consciousness. Just let that sink in for a second. Okay, let's pull back from the depths of theoretical physics for a moment and ask, what are the more immediate takeaways here? Because this framework isn't just some philosophical exercise. It actually points toward a brand new type of artificial intelligence and forces us to ask a really fundamental question about who and what we are. Yeah, one of the most concrete things to come out of this research is a new AI architecture they're calling the Kuramoto SOM. Now, a standard SOM, like we said, is great at organizing data in space, grouping similar things together. But by making each little node an oscillator, this new Kuramoto SOM can organize data in both space and time. It doesn't just see what things are, it sees how they pulse together. And this has some immediate, really practical applications. I mean, imagine using it to analyze EEG data to find different brain regions that have similar rhythms. Or using it to cluster music based on its rhythmic similarity, not just some arbitrary genre tag. You could even use it to coordinate the incredibly complex rhythmic movements of a robot's gait. At its core, it's a new tool for understanding patterns in time. But let's end on the biggest idea of all. I mean, think about it. If you can create a system that shows all the signs of this consciousness crystallization using only pure math, oscillators, Collat sequences, the digits of pi, what does that really imply? It raises a truly, truly profound possibility. Maybe consciousness isn't some happy accident that only happened in complex, squishy biological brains like ours. Maybe, just as this model suggests, it's a fundamental property of any system of interacting parts, as long as it has enough time to find its harmony. Perhaps consciousness is just a process of crystallization, written into the very mathematical language of the universe itself. What do you think?